Today, in this video, I'm going to show you how to do some of the problems in assignment 18-2-3. This assignment is shown here. The first page looks like this, and the second page looks like this. There's a table. I'm going to explain the table, how to do the questions on the table with some other questions. So I have these questions right here. Now, applying Coulomb's law, when I give you this table here, the first column shows you two charges, Q1, Q2. Please change into Q2. If there are a distance r apart, then the electric force between them will be Fe. Now, this 2 means when Q1 is doubled, 1 represents Q2 stays the same, and separation between the same. In that case, your force becomes doubled. Take a look, Q2 and R stays the same. Q1 is doubled. Q1 and Fe is directly proportional to each other. So when it's doubled, it's doubled. So we have double. We have double here. Here's double. If these two stays the same, when Q1 is tripled, force is tripled. These two stays the same. When Q1 is quadrupled, the force is quadrupled as well. Now let's take a look. What if Q1 stays the same, separation stays the same, Q2 is 5 times. Take a look. These two stays the same when Q2 and Fe is directly proportional to each other as well. So when Q2 is 5 times, Fe will be 5 times. 6 times, 6 times. 7 times, 7 times. Now, let's take a look. From 1 to 6, this describes how each charge affects the force. Pretty much, if Q1 is doubled, it's doubled. If 5 times, it's 5 times. Now let's take a look at how separation affects the electric force between them. When both charges stay the same, if the charges are farther apart, the electric force between them is weaker. How much weaker? Take a look. R squared is inversely proportional to the force. It's down here. So we can easily find the ratio this way. We can just square it and flip and put it under. So it has become 1/4 squared equals 1/16. What if the separation becomes 5 times? Square, flip. So it becomes 1/5 squared times the original force. It's 1/25. Let's take a look at the next one here. If the separation becomes 1/6, then what you can do here is, this is a fraction. We can square and flip, or we can flip then square. The number will be the same. So when you flip, it's 6. When you square, it's 36. So it becomes 36 of the original force, 36 times of the original force. And take a look at 1/5. If the separation becomes 1/5, you can flip and then square. So it becomes 25. Or you can just do square and flip. Okay, square and then flip. So you have this one here. These two have the same answer. What happens if all the numbers changes, all the coefficient changes? Then you take a look at the equation. It's Q1 times Q2 divided by R squared. So you do the same thing for the coefficient for these variables. You do 3 times 5 divided by 2 squared. Okay, 3 times 5 divided by 2 squared. So this force is 15/4 times of before. If it's 6 times of the charge Q1 becomes 6 times, Q2 becomes 7 times, and the separation becomes smaller, becomes 0.3 of the original length, then the electric force will become 6 times 7 divided by 0.3 squared. So it becomes 467 times of the original force. The rest follow the same rule. 3 times 7 divided by 5 squared. You can do the same, like this one here. In the second page of this assignment, there is a table. It meant the same thing. Meaning, when I write down 1, it means the charge remains the same. There is no change in the electric charge. And the Q2 is doubled, so it's twice of Q2. And this one represents the separation between them is 1. It doesn't mean it's 1 meter. It means it's the same as before. So the force will become twice as the original one. It's because these two sets the same, only charge 2 and Fe are directly proportional to each other. So when it's doubled, it's doubled. I'm pretty sure you can do the rest. And if you have any questions, please leave a message or remind. Thank you for watching. Have a great day.